And maybe I should just mention again that I'm from the IT University of Copenhagen, and I head a center, which is a research center for digital welfare. And my own research is in public digitalization. And I'm very much interested in information infrastructures as social and technical and political assemblages or achievements, you could say. So I was very excited to hear how detailed you were in explaining things in practice. Because trained as an anthropologist, I'm sort of addicted to detail and to everything to do with context and the everyday and places where things go wrong, even though everything was designed in a very sophisticated way and nothing could possibly go wrong and so on. So I think when it comes to making IT work, we have to focus there, and there's a very, great interest in society nowadays. So I think we're at a very exciting moment in time right now, where people know a lot more about how tech development is not just technical stuff, that it's really about making things work, and that there are human choices behind, and that technology, as you ended your talk by saying, really shapes us. So, and that it ultimately nowadays is becoming a question of how we want the future to look like. And I think your talk really highlights that the stakes are high, because we can do a lot, and we are doing a lot, but the decisions to be made all the way. I think we are seeing now how not only AI is taken into practice, but also ethics are taken into practice. So that the combination of the two actually needs to be taken very seriously, not just, in the very abstract way. So ethics as something that we use as a principle to govern our behavior, but also something that we are now experimenting with, because usually when we meet people face to face, we have a lot of ways of adjusting and detecting the impact of our actions and detecting how these principles actually work. But when we're at a distance, not so much. So it's not just about us as individuals being far apart, but also designers, politicians, decision makers, managers being at a distance of the places where these things are put to use. And I think we have to work with that distance very actively, because it's really about empathy in the end, the kind of empathy that is now being distributed in different ways. And I've actually heard philosophers speak about he's called Jared Saigon. He speaks about that we really need to be careful not to develop psychopathic machines. So that's really what we are sort of looking at, right? So what I would like now to do to have the dialogue is to touch on some of the examples that you used in order to unpack ethics as this very abstract thing even further. Because what does it mean, And I think one of your examples, and I actually really loved the OR, maybe we can come back to the OR black box also in your answers, because I have some examples here, and I wonder if you would like to reflect on how we can confront the issues at stake here. And they are ethical issues because they are about how we live with AI in the everyday, in the use situation, in practice. And the first is about AI, I call it AI at the shop floor. It's about de-skilling work employees. And I would like to relate it to your example with the lady with the cup of coffee and the home care situation. Because what is it that we're looking at? We're actually not looking so much as a patient as we're looking at a doctor who's not seeing the patient, or a nurse who's not seeing a patient. It's care at a distance. So one of the arguments in AI is very much about we need to replace routine work so that it's only the knowledge work that people will do and not all the boring stuff. But some tasks are routine, but not only. And I'm thinking about my own work as an academic. I have a lot of emails, and that's really routine, but not only, because it's also communication, it's also networking. We have a case in my research group, a PhD who did a study in the tax administration, where the customs officials had an AI introduced that would sort the packages in the airport in order to detect fraud. So poisonous toys and maybe even drugs and so on, they were sorted based on machine learning. I think they also used Lime actually at one point in order to try to deal with to make it more explainable. But the point here is that it's really about human-machine collaboration. And what is how do you see designing, okay, I'll backtrack a little bit. Sometimes people are afraid of being worked out of business by an AI and they refuse to collaborate with the AI, right? But they also sometimes are de-skilled because they don't see the deviant cases. So the home care may work in the case where there's nothing wrong, out of the normal. But when there's something out of the normal, when there's a deviant case, will that knowledge get fed back to the healthcare professional? Okay, you see where I'm going. So it's about the knowledge work versus the routine work, and if it's actually possible to eliminate some kind of tasks with AI and not risk both losing people and losing their skills. I'll stop here.
Yeah, that's actually a great point. I think it's kind of challenging sometimes to predict exactly what's going to happen in the future. So I want to say that when it comes to like the changes in the workforce, there's like you hear a lot of like the doom and gloom predictions, in particular about transport. Self-driving cars are just going to drive through the night. They don't need to rest and so on. And taxi services, these are all going to be replaced in the not too distant future. And then, like we saw at the beginning of the talk, also there's a lot of popular press, about how radiologists are going to be replaced. And then, like almost every specialty has some people in AI kind of nibbling at their toes. So we have projects where we have put a microphone between a family doctor, they're sometimes called general physician, and their patient, and we listen to their conversations and we try to pull out interesting like symptoms, when these symptoms started, and just information of that type. So my point is that there's a lot of work in AI, and a lot of people are saying this doom and gloom, like these jobs are in peril. And then people respond and they say, well, that's not true, because if you look at the same conversation comes up repeatedly, right? It came up with the industrial age, and it came up when horses were going to be replaced by cars. In the early days, there didn't seem to be much risk, in like everything was run by horses, and these cars are newfangled fads that's going to fade away. But of course, a lot of horses now are out of work, or they were during the industrial age. So they'd say, well, but then people respond to that kind of criticism and say, yeah, of course, but the drivers of horses are now driving cars, right? So it's not, people just learn new skills, and radiologists are usually the ones in healthcare who are identified as doing most of the like routine kind of work that you were talking about, the kind of work that requires a lot of rote looking at data, marking it off, and kind of going through relatively mechanistic steps. So people say, well,
who is responsible for trying to speculate a little bit about these things, as you think nowadays? I mean, who is actually should be in the lead here? Because I see your point that radiologists can be can do other tasks, but But we also have, like in Denmark, for example, a lot of hospital secretaries who were becoming report builders with the new healthcare infrastructures, but maybe, I don't know how they feel about it, but it was sort of not maybe their wish, right? So it's a change that is coming, and is it then on the local hospital? Is it something that politicians actually have a responsibility to predict a little more if we really want to go for AI in many sectors? I mean, just your bold view on is there a way we can predict, because it's serious for the people, who suddenly need to do the or have an upgrade of that qualification, or I'm being moved somewhere.
Yeah, so I think that the point I was trying to make earlier was that I mean, there's tons of predictions happening, and somehow what ends up actually being the case is none of the predictions that were initially being made. Like whatever the case is going to look like in the next 5 or 10 years, it's not going to be what like computer scientists like myself and Jeff Hinton might predict. It won't be what clinicians might predict. There's a lot of uncertainty that ends up happening, and I think trying to predict the future and saying this is where we're headed is challenging. But it's not to say that we shouldn't prepare for contingencies and so really, I think you ask like who should be responsible for making some of these predictions, and I think really it's everybody. It's and this is kind of a cliche thing, but it really will take as all stakeholders at the table, so to speak, helping to make short-term decisions as to where we want to go next, and also to kind of recognize challenges before they occur. And again, sometimes we might spend time expecting challenges that don't actually come to pass, but we need to receive input from all stakeholders. So in this case, I think computer scientists need to be there because they kind of understand how the machinery works, at least they're supposed to. We need healthcare individuals because they understand how care is actually provisioned, but more of the domain. Of course, patients, how are their data going to be used? There's a lot of challenges in Canada and in the UK of like, in the United States of like patient data being used for reasons that they didn't necessarily agree to. Politicians who end up making the laws, business owners, like everybody needs to be at the table. And I think, so that's kind of cliche. I think maybe also almost as cliched is that we need everyone to be educated. There's always been a bit of a challenge.
Can I ask about this thing about the use of health data, because that's something much debated here in Denmark at the moment, and the proponents would say that we have the data, we have very, very elaborate public registries, we have a high level of standardization, lots of data is being collected, but we don't have the political will and we don't have the infrastructure, people would say. Whereas the critics would say, well, but there's so many ethical issues about safety and security, and there's not, a GDPR is not enough. But then I would like to add another point, which is what I see as a sort of ethical concern that is not being debated so much. And I wondered if you had a comment on that, because it relates to the sort of not just the quality of data, but also like privacy in the big way for groups. So if you have DNA registers, for example, you have a disease, I have a disease, and I would want the healthcare system to do everything it can to cure that disease. But when I give access to my DNA, I also may, breach the privacy of my children, who are also connected to that data in some indirect way, but still. And also, and another thing that is happening here is that the church books are being digitalized at the moment in order to look for, with machine learning, to look for health issues in the generational perspective. But then you break your privacy of your forefathers and foremothers and whatever secrets there are in the family from generations ago. And are you allowed to do that? So what about the privacy that goes back and forth in time when it comes to health? I mean, isn't that something that we should discuss also when we talk about making available data for clinical research.
Yeah, I think I want to talk about privacy in a second. I think just tying with what we were discussing a moment ago, and bringing in like a diverse set of voices. I think like these are problems without any kind of clear like single solution, and really what it's going to take is everyone to contribute on their points of view, but to do that effectively, they need to kind of understand some of what the challenges really are. Like I think just to bring it to this current question, I think to some extent a lot of computer scientists in machine learning, like traditionally, privacy wasn't really a question we had to deal with, right? Like we focused on the algorithms, and then we got data, and typically the data used to not be so critical. There were pictures of cats and dogs and that kind of thing. And suddenly we're presented with much more meaningful data with much more societal consequences. And the regular way that we were doing things, 5-6 years ago, doesn't really apply anymore. So we end up with kind of a tug of war between like computer scientists on one hand and clinicians on the other. I can speak only to my own experience in Canada, and specifically in Ontario, the province of Ontario in Canada. So the provinces in Canada like independently house their own data warehouses. And even though there was a lot of political will to connect the Ministry of Health in our province to our research institutions in machine learning, and a lot of positivity was put into that relationship for a very long time, when it came down to actually sharing data and results back and forth between the data warehouse and the computer scientists, all those grad students and postdocs and so on, things kind of grind to a halt, because like there's this traditional ways that the data holders would deal with data, and who gets access and where do they physically get access, how do they, what procedures they have to go through. That doesn't really connect with how computer scientists were working. And then, like I said, there's kind of a tug of war. So computer scientists are saying, don't de-identify the data, don't remove any data. These neural networks need complete access in order to learn things. And if we artificially blind the neural networks to like covariates, gender, age, other things, it won't be able to succeed. But of course, that kind of talk does not bode well for people in healthcare, for whom privacy has been one of the core principles for a very long time. I guess the two last things I want to say on that topic is that, like in response, there is some work in the computer science community to kind of try to bridge that gap from their perspective. So like automated ways to like improve on de-identification processes, so you don't have to spend time like removing names, professions, other identifying information from healthcare records, but really like arbitrarily. I showed an example of trying to do something similar with video. So like identify heads and block them off and obfuscate bodies within video. So like there is kind of an effort to try to bridge the gap and show that, okay, well, we can de-identify video, we can remove things and still retain useful information, so we can still make good predictions. Meanwhile, I think the healthcare community has been very interested in opening up some data too, but like healthcare is connected to patients, and the legislation around the use of these data. So it's not a simple matter of convincing a doctor that you ought to hand over some of your data. It's much more complicated and long-term than that. So to make real meaningful change is gonna take time, but like I said, it's gonna take input from various stakeholders. There's a paper by Wall et al., W-A-L-L, where they talk about decision-making processes and how to kind of organize the decision-making process. How do we distribute data? How do we make use of the data? And they talk about stakeholders like I've been talking about. They also talk about coming to consensus about like what are the actual facts and what are our goals and values? What are the norms that we apply to our decision-making processes? And like we have to have some agreement on all of those things before we can really move ahead. And even there, there's a lot of disagreement, right? And just to like reemphasize what I mentioned a moment ago, what are the norms aren't always agreed upon. Like there's some of my colleagues I work with, like the vast majority say yes, like we're only going to make use of the data in our machine learning tools if they've been de-identified, and we respect that this is kind of a time-honored tradition, and we will do whatever the medical community says is necessary before we can even get a sliver of these data. But some people, and even people in healthcare, some people we talked to in the States from some hospitals down there said there should be no privacy at all. All the data should be open. If a doctor made a mistake, I want to know exactly who it was so I can fire them, they said. You know,
I think
and
in the interest of time, we should probably move to questions from the audience. I would like to thank you for this round, and over to Christian.
Thank you, Brit, and thank you, Frank. Yeah, we've got a few questions coming in from the audience, and please keep them coming. I'll try to read them out. I have one question from Renee about it touches on cohorts, the size of the country. So in many countries, it's not really an issue. US, China, India, where you have large populations. But Renee, do you want to ask the question to Frank yourself?
I can do that. Can you hear me?
Yeah.
Good. Well, it's just I'm in a company where we work a lot with AI and machine learning, and one of the things we can see when we advise a lot of people is that the bigger countries here, like the US, China, India, they get so vast data, so it's easier for them to actually train and use AI, for instance, in healthcare. And if you have like the Faroe Islands, where I've been talking to the hospital up there, they would like to start using that also, but it's a bit difficult when they have 50,000 people, right? So the time it takes for them to actually train, looking at a scanned picture, whether there's cancer or COVID-19 for that matter, is going to take them years and years and years. So are there any discussions? How can we actually exchange data? Of course, living up to the GDPR rules, but but still that we can actually get data, for instance, from the US, China, India, wherever, where we can actually see that this person has cancer, because now we have 1 billion of these pictures instead of, building that database ourselves.
That's an excellent question. This is something that we also face in Canada. You know, the population is about like 37 million, and and then like I mentioned, we usually only get data on the province level, so on the order of about 5 or 10 million people, and so trying to do anything really reasonable on that order of magnitude when the people across the border have access to hundreds of millions of potential patients is going to be a challenge for a very long time. Now, on one side, again, like I'm mostly aware of what the computer science community is doing, and you're probably aware of some of this too. There's like a lot of researchers are trying to make sure that these results are like what they call like the democratization of machine learning. So, for example, there's a model called Brit, which is from what is it? Not Google. Or GPT from OpenAI, right? So these are models that only these massive companies can train on, and training them from scratch is something beyond the abilities of, I think, most countries. But we kind of rely on the more fortunate to kind of share with the rest of us. And this is a kind of, actually, this is a principle of computer science, is that we traditionally, I mean, at least the researchers would try to make their code freely available, and in that case, a model will be available online. So some researchers try to take that method and then trim it down a little bit so you can do processing in like 1/10 of the time, which can help a little bit with resources. So you don't need to invest in these supercomputers. And other areas of research are focused on fine tuning. So like you might get a model trained on, say, American data or Chinese data, and then which has local specifics that might not apply to our situation or the situation of a particular group of people, but there's still information there under the surface, like the fundamental issues, like all human beings are fundamentally the same under the hood, with some exceptions. So that's the kind of data that these massive neural networks were able to train. If we can just fine tune the data to our specifics, then we can get the benefits of this massive exercise, but we can make it more applicable to our local situation. So I think, we have to, rely on the Googles and the Facebooks to share their models with everybody freely. And so far that we've been lucky that that's been the case. And then we can focus not on training these models from scratch, but just on tweaking the model slightly to our own particular situations. And then of course, applying some of those techniques I kind of brushed on to make sure that, they're actually learning things that are reasonable. Beyond that, like politically, this is also very difficult. So far, there's a bit of international movement on AI, but so far it's still pretty localized in different countries. I'm mostly familiar with like England, France, Canada, there's in each of these countries, there's kind of national strategies for using AI within those countries. And each of them are talking about governance, use of data, just within those countries. And there's a bit more conversation between the countries also. There's that standardization effort at the ISO that's trying to get people on the same page. But unfortunately, there's a lot of differences that are yet to overcome. So like when I was observing some of the conversations that were happening at the international level, some countries, were of the mind that companies should be free to record and use the data as they see fit, and other countries were bringing up points about how governments should be able to gather data and use those data for surveillance as they see fit. And other countries in the middle, they don't have the political power of those countries. We're kind of a bit more restrictive as to what should be used. But I think as long as people are organized in these collections of countries, like through the ISO or otherwise, the United Nations possibly, we'll be able to get some consensus. But again, just to wrap that up, unfortunately, honestly, I think that just like we've seen powerful countries sometimes turn their backs on international agreements, even if we spend a lot of time and effort organizing and trying to make sure that these big countries and powerful countries sort of play fairly by international rules, there's nothing stopping them, I think, from turning around internally in their own best interests. So I think regardless, we should just keep on working together in the spirit of cooperation and try to get some like uniform consensus on at least some of the technical details. But we also have to be aware that it's not a perfect world.
Thank you, Frank. I'm gonna move on. We have a few other questions, a couple of questions that touch upon this black box that many people see machine learning and AI as being. Frank, the question comes from Paula, who's asking, in your experience, making machine learning more explainable for stakeholders, especially those who are not super tech savvy, people like myself, for instance, what works best? And a follow-up question to this from Todorka is, first, she thanks you for sharing the expertise. What are the potential of implementing virtual reality and augmented reality for visualization for this explainable AI? Would you talk a little bit about that?
I think those are great questions. So I think one thing I was trying to emphasize earlier is that there's going to bring about like the best possible outcomes in the future. There will have to be a little bit of cross-pollination of ideas and techniques, theories from different domains, right? So in Toronto, for example, there's a program where medical doctors or students in medical school are taking programming classes. So they don't have to be world-class programmers, but at least they understand a little bit. They have some familiarity with the vocabulary, so that when computer scientists like myself come to talk to them, we can at least kind of speak the same language, so to speak. So I think there's a little bit of coming together, but fundamentally, I don't expect that a clinician should understand how to write a neural network from scratch, how to train it, and even really, if we open up the hood, like I did briefly on that one slide with the math, like what that even means. I think it's unreasonable to expect anybody, even many computer scientists, to really understand what that means. In my experience, a good way to communicate between computer scientists and clinicians has been in terms of the data and in terms of, I guess, variables that the clinicians are used to. So I'll give you two examples quickly. In the case of surgical safety, normally that is in terms of video. And one of the AI techniques looks at video from inside the body during a surgery. And you can see basically some tissues, and you can see the instruments like the graspers and maybe like a scalpel or its equivalent operating. And occasionally there's a nick, and then there's some blood that occurs. Sometimes it's intentional or unintentional, but regardless, there's some blood that's coming out. And a pure, like an uninterpretable model will just say, at this moment in time, there's bleeding, and then leave it at that. But what we tend to do is we use something called attention. And it's a way to kind of look just into the neural network and say, well, the neural network, when it's making its decision about there being blood in the scene, it's paying attention to this region of the field. And this is kind of what I showed with those heat maps showing the pixels around the shapes of the animals that were being recognized. Clinicians respond to that. So if we say, well, it looks like there's bleeding in the scene, and this is specifically where the AI thinks bleeding is occurring, then clinicians are really happy with that. They can say, yes, this looks like bleeding. So the eye is kind of drawn to like, a certain region, and we understand what the AI is paying attention to. The second brief example I want to mention goes back to another company that my students started called Winthereik, and that was the woman talking to Siri is the use case for that company. The company listens to your voice, and it detects things like anxiety, depression, and Alzheimer's disease. But instead of saying, your risk of Alzheimer's disease went from 85% to 95% today, when we went to doctors with that kind of result, they didn't care. It's like, this doesn't mean anything to me. We can't do anything with this information. It's useless. But then when we use a similar technique to kind of show what were the variables that were being paid attention to, and if those variables were in terms that the clinicians already understood, then we made a lot of progress. And then the clinicians could actually make use of, put those decisions into practice. So for example, a variable that makes sense is that somebody's tone of voice becomes very flat, and a lot flatter than it was yesterday. Or maybe there's more pausing happening before the word is chosen. Maybe the words themselves carry a lot more negative emotion, affect, or they're really simple. So instead of saying detailed words like sedan, they might just say car. It sounds relatively simple, but if you have, 50 of these interpretable features, and the AI says X, Y, and Z are what I'm paying attention to when I say this person seems to be more anxious than they were yesterday, and the clinicians can say, oh, good, this is an instance of them having executive difficulty, maybe emotional difficulty, memory issues, and they can think in those terms, and then they can take action on it. So there's another paper by Lipton, L-I-P as in Peter, T as in Toronto, O-N. And it covers different ways of dealing with explainable AI at a high level. This is a theory called decomposability. If you can decompose a problem in terms that we can understand, then you can make progress. So I think that's been helpful for us, is to kind of present the explainability to clinicians in those terms.
Thank you, Frank. I know, Brit, you have one more question, but before we go to that, we have one question. Maybe Jens, would you like to ask the question yourself? You have to unmute yourself if you're interested in this. Yeah. We can't hear you, Jens, but so I'll ask the question regarding privacy. How do you guard against reconstruction of training data, personal data from the deep neural network models? Frank?
Excellent question. Right, there's actually a paper that came out recently that showed that you can reconstruct like whole instances of this exact thing. So the model isn't just like a structure. You can actually tell something about what the what data were used to train it. Actually, we have a paper on this topic also for medical records, the text. When a neural network looks at text and it learns a representation of what that text means, it'll kind of find groupings of words that mean similar things. And then therefore a hacker or even someone without malintent can use that information to say like this person's name is more associated with this disease. And through a couple of statistical steps, you can be really confident that, a particular person's name, like a particular person had a disease. There's lots of techniques to this too. Like, unfortunately, like I mentioned earlier, a lot of research is like the Wild West, and there's no single, because it's such a new field, there's no single consensus that is like the best of all worlds. Our method involves taking training data and actually changing every element of the training data to something relatively similar. So we just swap out words for other words. And there's a paper in JAMIA that shows how that works. So like, you'll never, you don't have to worry about de-identification because every single element of the input is changed. Now we haven't proved that that technique is foolproof though. There's always like blind spots to security. I think, despite that I mentioned that there's no consensus in how to truly remove information from the training data. I mean, you probably heard of differential privacy, which is actually a collection of techniques where, we'll add noise to the data. So we'll obfuscate the data in some way, not even to the extent that we do in that example I mentioned, but it's kind of like that example I showed with the bus and the dog and the insect, where you add a bit of noise to data, and then the model gets really confused. Fundamentally, I think that technique has been working pretty well. And in a lot of the papers that describe differential privacy, they actually go through proofs to show that this will save training data from being reconstructible 95-98% of the time, which sounds good, but if you have millions of records, even a 0.5% of false negatives will result in a lot of data being exposed, tens of thousands or 100,000 of patients potentially. So I think it's still a work in progress. Most of the effort will be in adding noise to the data or modifying the data in some way before it's given to the training algorithms.
Thank you, Frank. I'll hand it over to Brit in just 1 second, but a couple of questions have come in because you mentioned during the slide with the Siri's chatbot giving advice on how to end your day. You said AI is not machine learning. Mm-hmm. In one sentence, how would you, or 2 sentences maybe, how would you define, or what's your definition of AI versus machine learning? Do you have a quick way of memorizing that, or your take on it?
So I think machine learning is a part of AI, and AI is a more general idea, a general concept or umbrella. So I think the main difference is that at a very high level, all of artificial intelligence is software that's meant to mimic intelligence, but that can be machine learning or something else. So Siri, for example, is artificial intelligence because she's meant to mimic a human, but she doesn't actually learn from data. That's machine learning. Machine learning is a subset of artificial intelligence that's also meant to mimic a human, but it does so by itself. You give it lots of examples, and it's meant to learn the patterns essentially on its own. So machine learning is artificial intelligence, but not all artificial intelligence is machine learning.
Thank you very much. Brit, I know you had a question to finish off.
Thank you so much. You mentioned explainability, and you talked about lack of definition, that there's also somebody calling it interpretability. And I wondered if we could speak a little bit about who it is that needs the explanation, and whether, because I have some ideas for something that I think is needed coming from a qualitative research tradition, that, for example, in the public sector, when AI is used here in Denmark to make a risk score because caseworkers are overburdened and so on. So which cases are the most urgent? If you have vulnerable families at risk, they are being asked to use a risk score that is being based on AI automation. So what about, who in that case, what does explainability mean? Because I know it's a very technical thing when you describe it. It's about probability and statistics. But if we speak about a practical situation where a caseworker is having families that are in need of welfare one way or the other, they also need to be able to explain to the citizen why or why not a certain benefit is given, right? So is that another version of explainability? How do you see that?
Yeah, that's definitely a consideration. And I want to also, there's a question a few moments ago about augmented reality, and I'm going to try to fold that into this question, this answer also. So yeah, essentially the way that I conceive of the difference between explainability and interpretability is that explainability is normally about the model, and interpretability is about a decision. So explainability will say, well, the model that's trained to recognize cancer, I can explain how it works because I can identify, it recognizes edges and colors and other things about an image to make that decision. Whereas interpretability is saying, well, I think this is cancer specifically because of, I mean, I'm not a dermatologist, but, about the shape, the color, these are the things that made my decision in this particular case. So that's how I think of the difference between those two things. Now, that being said, I think we're mostly talking about interpretability, right? So if something's made, a decision's made, how do you explain, how do you interpret that? How do you let everybody know why that decision was made? And that's going to be different for different people. I think a clinician looking at a like radiology image would appreciate certain kinds of information that maybe the patients wouldn't, and maybe the politicians also wouldn't. So I think there's, I don't want to say that the solution is always more AI, but there's some work that actually tries to explicitly learn explanations that are the most interpretable or to different stakeholders. So it'll actually modify what it tells you depending on what it knows about you. And I mean, of course, it has to learn something about you. It has to learn, like, what have you found useful in the past? What have you found confusing in the past? And gradually the explainer will realize, okay, for you, I need to explain things in this way, but for your doctor, I need to explain things in that way. So I think that's going to be a crucial thing also. Like, not everybody will get the same interpretation necessarily. Now, I mean, it's going to be a big challenge, I think, right? Like, just like neural networks in the first place can make mistakes. If we're making explanations using neural networks that can also make mistakes, then the explanations themselves can also be faulty. And if we're giving different explanations to different people, it's going to be very difficult to come to any kind of common core understanding between everybody. But I think that's also a problem to recognize.
To err is human, but to err is maybe also machinic. So it's just a question of what kinds of errors, maybe or do you think that that's not the case?
That's definitely the case. AI makes a lot of mistakes. Sometimes we're asked to produce systems that are perfect 100% of the time, or at least we get the feeling that people expect AI to be perfect and so much better than humans, because humans are so lousy with data and information, they think. But no, like AI makes mistakes all the time. And even like these high accuracies that we're seeing can still, like I mentioned a moment ago, result in, catastrophic decisions for, tens of thousands of people. And I think the main thing is to recognize is that AI will make mistakes, period. The second thing is that the mistakes it makes will be very different than how we make mistakes. Like, there's very little that connects artificial neural networks to biological neural networks. How we make mistakes is different than how neural networks make mistakes. And I think it's going to be a long time before we really have, good psychologists for AI to really truly understand this is how AI thinks. I kind of think of AI or machine learning as like an alien mind, like we can understand it some of the time, but some of the time it's completely separate from us. So this is going to be a challenge. We're not. The road isn't nearly complete yet. I just want to mention before, just very quickly, because the question was asked about augmented reality and explainability. I think these things are connected to some extent also, because you can imagine if someone's looking inside the body while they're performing a surgery, we don't want to only know that there's bleeding, but we want to know like where the bleeding is, which is an instance of like interpretable AI. But there's some work being done to make that happening in real time. So while you're operating, the AI will come up and say, there's bleeding over here in this particular area, and the surgeon is directed to fix it. Or an AI might say, there's a risk that an error could occur, like in the next 5 minutes or something. Be careful. So there's a paper of that also from the University of Washington, like predicting surgical challenges, a few minutes before they occur, and then showing the user in real time, like in augmented reality. But I think that also introduces problems. I mean, nothing to do with the AI's error, but if we're constantly being bombarded with these alarms going off caused by automation, then that can cause distraction, and then distractions can cause error. And if the human operators really dislike that distraction, they can ignore it, and then they'll end up ignoring a lot of the positive indications from these systems as well. So I think augmented reality is sort of going to be an extension of explainable AI, but it's going to have to incorporate a lot more understanding of like design and what we call like human-computer interaction.